Hello, so I'm Alice, one of the fourth years, and my DAC is on ophthalmology. So for this section, I'm going to kind of go through visual pathways and loss of vision. This is a concept that I found really challenging until I understood it. And now it's something that I love when it comes up in an exam because I can draw it out and I can figure it out. So we're just going to run through the page and explain it because I thought that was easier because it's quite a difficult concept to understand when you're just reading it. I think it makes a lot more sense if someone explains it to you. So yeah, like I said, this layout is slightly different to the other pages, but don't worry about writing anything down or anything because it's all on the website. So what kind of makes up your visual pathway? So you've got your optic nerve, which is like a sensory nerve, and it's what allows us to see. You've got your optic chiasm, which is where both of the nerves are going to cross over. You've got your optic radiations, which you can see here, which come from the lateral geniculate nucleus, so the LGN, and it's where the optic tract kind of ends. It becomes an optic radiation after the LGN to the primary visual cortex. And then you've got the visual center of the occipital lobe, which is where your brain is kind of processing the signals that have been sent there. So, visual field defects. So, this is a very typical question. So, you can see here how you've kind of got a section of four. So you've got your superior areas and your inferior areas. And they'd be like, what area of the brain is damaged? Say if you lose an inferior bit of your vision. So the way to remember this is PIPs. So the parietal lobe is inferior loss of vision and the temporal lobe is superior loss of vision. So there will be some questions on this and I will explain it. But essentially, if you have loss of vision in this left lower field, you can see that that is going to be the right parietal lobe because PITS is inferior. And because you've got that crossover, because of the optic chiasm, it's going to be the opposite side to the loss of vision, if that makes sense. Because if you follow the tracks down, it's going to the opposite to the one you can see, if that makes sense. So yeah, and then this diagram here is just showing kind of how we view things and how we process it. It's just kind of to help you figure it out. So yeah, the optic nerve is giving sensory information for vision. And then this diagram here is really, really, really important and is what I used to learn before every exam. So it's damage to the nerves at certain points in the eye and what vision loss this causes. So if you look at number one, we're completely occluding the right optic nerves. Yeah. And that, if you're occluding both of them, you're not going to be able to see out of that eye. So we call that total right eye visual loss. And then number two, so we're talking about the optic chiasm a lot, which I'm assuming you guys have learned, which is where your optic nerves are crossing over. So if you get it, where the optic nerves are crossing over, this is where it's really useful to, in your exams, draw this diagram out and follow it. You can see that each of the nerves that cross over are supplying your temporal visual fields. So you're going to get bitemporal hemianopia, which just means half of your vision loss on both sides of your temporal. And then if we look at number three, which is just the optic nerve of the left eye, but it's not the part that crosses over in the optic chiasm, you're going to get left nasal hemianopia, as it's providing kind of the lateral side of the eye, but that means that it's going to project into the nasal view. So if you look at this image here, you can see that the area that is medial in the eye is giving your temporal view. So you're going to get left nasal hemianopia. Then if we look at number four, so it's occluding kind of both optic nerves, but one's crossed over at the chiasm. So what you're going to get is right hominis hemianopia. And that's because if you follow the tracks, you can see that it's blocking the right side of the left eye and the right side of the right eye, if that makes sense. So you're calling this hominis hemianopia because hominis is the same. So it's both on the right side, your vision of your right side. And then where it gets a bit complicated is 5. But remember, we spoke up here about your optic radiations. So essentially, if the loss of damage is at the optic radiation, what happens is your macula is spared, and the macula provides the central vision to your eye. So like this. So when this area here is damaged, you're going to get macular sparing of the eye. So it's kind of the exact same. You follow the nerves, the optic nerves, and figure out what part of the eye, but you're going to have macular sparing as it is the optic radiation, if that makes sense, which I hope it does. If you have any questions, feel free to email me. But yeah, thank you for listening.